Hello to everyone and welcome to today's webinar. My name is Tanner Swift and I'll be your moderator for this session. I'm pleased to introduce today's speaker, Alex Afshar, who will be later joined by Gary Martin. But before I hand the mic over to our presenters, I do have a few housekeeping items to cover about this presentation. Today's webinar will be recorded and made available on demand after the live session. We will provide you with some of those details at the end. Also, we'd love to hear from you during today's presentation. If you have a question for our presenters today, please submit those questions through the Q&A panel here on WebEx, where our wonderful panelists are ready to respond. If you experience any audio issues, please use the call-in numbers displayed on the chat screen. I will post it once again momentarily. Without further ado, I'd like to kick things off by welcoming Alex. Alex, right over to you.
Thanks so much, Tanner, for that introduction. And for that broadcast quality voice, or should I say podcast quality voice. So this is welcome everyone. This is part 2 of Agent Management Lifecycle webinar. We did part 1 last month. We covered some general concepts around monitoring as code, and then we delved into a hands-on portion covering a couple of use cases for hands-on Ansible deployment. Today, we're going to go ahead and continue that, the rest of the agent management lifecycle capabilities of AppD. Today, we'll talk through a Kubernetes deployment. We'll have a hands-on portion that will do basically help us deploy a cluster agent and then instrument an EKS cluster. Kubernetes cluster and AWS environment, and then we walk through observing the instrumentation and then enabling sort of auto-instrumenting the applications running within a particular Kubernetes workload. And then we'll cover Docker agent. If we'll just do an overview of quickly how do you instrument applications running within a container, and then I'll hand it off to Gary, who will cover the Pivotal Cloud Foundry and do an overview and speak to how you instrument applications using what we have available for PCF. And then we'll have a resource and then QA section. Of course, we have moderators. My colleagues are moderating the chat, so you can go ahead and post questions throughout the conversation, and they will answer it. For any questions that we don't get to, we'll circle back with individuals. And so let's go on and jump into the Kubernetes hands-on portion. Now, in this scenario, we are doing, like I mentioned, using a cluster agent deployment to monitor the cluster and then auto-instrumenting the workload within the cluster. There's some tools, obviously, for your Kubernetes deployment that you need. And this presentation assumes certain level of knowledge around how to manage and deploy Kubernetes clusters. So as a requirements, you need certain tools. Those are all outlined within the documentation. I won't delve too much into all of that stuff. And then you need a metric server deployed on Kubernetes because they're not usually installed by default. And then you need a server visibility license. These are like the important requirements you should keep in mind while you check the documentation. And then you can use a sort of an image registry, container registry. I use Docker Hub for some of the stuff that I'm showing here, but you can use any of the available ones we support. And then just generally for me, I'm using for my demo environment, I have a AWS EKS deployment. I already have metric server installed. I use a pet clinic as a sample demo app. And then I'm using the operator and agent images from Docker Hub for AppDynamics. And then I'll sort of use kubectl to do the basically all the deployments, as opposed to using a Helm chart. Just easier to demo that stuff for me right now. Okay, so let's kick in. And then this is a pet clinic application. This is simple Pit Clinic application. If I bring it up, you'll see there's a cloud version, which allows you to actually do deployments onto Kubernetes. Okay. I also use like the simple non-cloud version of Pit Clinic, and so that would be one where you can actually install a monolith implementation, and so without having to do the cloud deployment. So in other words, you'll just run a JVM, but I'll show you how to maybe possibly even do the packaging of the running Pit Clinic and run it, be able to push into a Docker container and run it, have it monitored. So that would be the second portion. But for the first portion, we're just going to look at the cluster agent deployment. So one of the steps we have to do to begin with, there's a two-step process. I'm going to go ahead and jump into the documentation right away. And like I mentioned, last time we did this, we covered the Ansible portion. This time we're covering sort of Kubernetes, Docker, and Cloud Foundry portion. And when I go into Kubernetes, I am actually, you're looking at this particular use case here. Okay, I want to auto instrument the application using a cluster agent. What that will in effect do will deploy a cluster agent into my Kubernetes, or rather AppDynamics controller, and I can start monitoring the cluster as a whole. So it's a two-step process. For one, we instrument the cluster, look at the stats coming through for the cluster, and then, but that doesn't necessarily mean that you have all of your applications that are the workload that's on the cluster being monitored separately within the application scheme. So the second step of that is to enable auto instrumentation, so all of the applications running within a particular cluster and namespace, they're all being monitored. So that's a two-step process. So first thing we're going to do is go ahead into the download directory, or rather portal, and I'm going to go ahead and pull down the agent. If I can get to the cluster agent deployment. And you'll see that here. I don't necessarily want the Java agent at this point. I'm using, in this scenario, I actually want to pull it onto a Linux environment because that's what I have set up with AWS. And so with that, just to show you my environment quickly, this is my cluster, my implementation. This is my AWS console. I have a bunch of stuff running. These are all the nodes that are part of the cluster group. Okay, this is nothing specific to our AppDynamics. It's just that I created a cluster, went ahead and set up a cluster through Terraform, and I set up all the necessary resources. Of course, I'll take this down after demo, but here you will see all of the resources for this cluster that were deployed, and these are the these are the VMs that are basically for nodes, if you will, in that terminology for Kubernetes, and these will service the pods and everything that gets deployed as part of the cluster. So let me go back to the cluster really quick. That's the environment that I'm deploying to, and here, just to show you some Kubernetes general. You'll see some already. I've already logged into the AQS cluster. This is my Mac, and I have the kubectl stuff all installed. You see some namespaces running here already. I am going to go ahead and delete the AppDynamics one because I want to actually start and show you this from scratch. So you see, I had already something running prior. So what I'm going to do is go ahead and, well, actually, I will leave this alone for now, but I will walk through the steps for you to see how we pull down the agent configuration. The first step is, from a documentation perspective, we need to go ahead and actually pull down the cluster agent itself. I am using AMD 64, so that's the one I'm going to pull. You might be using ARM architecture, but I'm going to go ahead and use that simply to pull down the agent information, the cluster agent. That's the first step you want to do. And what I'm going to do is go ahead and make a directory called download demo and cd download demo. And then I'm going to go ahead and curl and pull down everything. Okay. Now I've done this already. It might take a little bit on my environment to pull down the whole agent. Oh, no, that was faster. Okay. That's probably because I'm off VPN. So what I'm going to do now is go ahead and expand this directory and get into the unzip directory. You'll see right off the bat, there's a couple of important files you need to actually work with: cluster agent operator YAML and cluster agent YAML. So the operator YAML is obviously the AppDynamics operator that needs to be deployed into AppDynamics space, right? We're talking about this deployment here. And if you consult the documentation, it'll just walk you through all of that, but we're going to go ahead and look at that really quick. And we're going to go ahead and look at this. These set of steps. Install the cluster agent first. That's what you want to do. And you can obviously, if you had to build the container, the operator image yourself, you had some sort of need for custom configuration. But here, what I'm going to do is go ahead and dip into this scheme. Okay. And what I've done here basically is, after downloading here, I am going to actually go ahead. There's areas where you have to actually install the metric server. Like I mentioned, that's a Kubernetes metric server that doesn't get installed by default. So you would follow through that step to begin with. Here, where we've gone through and unzipped the cluster agent. Now, we have to go and create a Kubernetes namespace, which I've done here already. You'll see the namespace here already created. And when you create this namespace, it's empty, it doesn't have anything in it. When you go ahead and deploy the operator, there's no change in the operator itself. You just simply go ahead and create it, and it will deploy into the AppDynamics space. Okay, so that's the idea behind that. You see the namespace AppDynamics, which requires that you actually create it to begin with. And that pretty much creates the operator. Now, you're not done there, of course, because now you have to go and generate the secret that's associated with your controller. This is the reason for that is obviously is the access key secret that you have on your application. And if you go and look at your license page account, it's this access key, which I won't show you, but that's the key that you need to feed into your kubectl commands to generate the generic key that's used for the application or cluster agent to communicate with the cluster, or rather AppDynamics. So in this scenario, I will use that access key. Of course, I'm not going to put that in here, but I've already done that step as well. And now comes the fun part, which is basically you have to get into cluster agent itself. So as of when I go through and I get to this step, I only have the operator deployed into the AppDynamics namespace. And here, what I'm going to do is go ahead and provide all of the information that's necessary for communicating to the controller. You see, these are all the normal agent parameters you provide that, talking to the host, the account name, you pull the agent from an agent registry, and I'll show you an example of this actually. And this is an edited version that I pulled in a little while ago. Let me just pull this off really quick just to make sure I don't have anything secret in it. I think everything is fine in here. Okay, I will throw that up in a second. Just bear with me. I just wanted to make sure. All right, cool. So here's what I have instrumented already. And this one, you can see that I already instrumented this and ran this, and you see that the cluster started to report. But this is the actual cluster that we're talking about with Pet Clinic. Okay. Pet Clinic cluster 1. So now what you would change is basically your cluster name is defined here. This is your URL for your SaaS or on-prem controller, your account name. You're pulling the agent, whichever version you need cluster agent off your Docker hub. Okay. So the first step to pull download the bundle with the cluster agent information in it, because that's going to be used to configure where we're going to pull the cluster agent itself and start configuring stuff. That Docker hub here is what we're talking about, obviously. If I had to look at it really quick, I think I have that. I have that already. But that would be basically a hub Docker. You're talking about AppDynamics here. And that's where we're pulling all of the cluster agent information here. Okay. And from there on, service account name. And then we're talking about the namespaces that we actually want to start monitoring, right? So again, if I look at this very quickly, I have a bunch of namespaces. All of these are different namespaces that I started deploying stuff into. These are the ones I created. This is the one for agent, cluster agent, and AppDynamics cluster agent and operator. And these are, of course, default that come with the deployment. And I'm saying that I want to look at everything that's in this demo namespace. Okay. So if I wanted to, say, get pods for that particular and see what's running already in there, I would just look at it and see what we have. Oops. And I have a bunch of, well, this is a monolith, and I just have one implementation here. In this scenario, as well, I can look at what services are running. And this is a service that's running. So it's a service deployed with a load balancer that pushes traffic to the pods that are servicing this particular workload. And if I wanted to go ahead and look at that, I can certainly do that. And these are just cute little pets here. I kind of want to stay on that home page all day. But this is it. Oops. Have here. So we have this workload. It's deployed pet application, pet store application, and then we I think I'm trying to see what's going on here. And that's the deployed application. That's what we're monitoring as is here with our installation. Okay. Now, if you go in this cluster deployment, like I mentioned, when you start it up, I already have that defined. And when we have this, we change the cluster agent, we configure it as such. Here's a lot of parameters that are already defined in how you want to configure your stuff. We go ahead and actually run Kubernetes create off of that cluster agent, which I did at some point earlier today. So what that does is actually deploy the two pods into the AppDynamics space. And then so in terms of, and then you can go ahead and validate your installation. It takes about 5 to 10 minutes to actually get to your see stuff coming through. This is why I have this already running right now. So that is, it took about 5-10 minutes. But if you go into it now, you'll see all the pods that are running within this demo space, inventory, events, all of that stuff here. All the metrics from the cluster itself is being collected. So you can imagine as soon as the metrics come in, we start baselining cluster metrics and health. And you can create monitors or alerts off of everything that's happening in the cluster. So that's for cluster health itself. But the pet clinic application is not really monitored per se within the application, because we're not monitoring individual services that are running, or rather the application in our application workflow. We're monitoring the cluster. So now we need to go and use the auto instrumentation scheme to say that, you know what, we'd like to be able to monitor automatically, because that's the auto instrumentation scheme, everything that's running within that namespace, or we can be very selective and decide how we want to go ahead and do that. So in that sense, I can go ahead and show you some of the documentation around that. We are obviously using, let's see, we are going through and looking for using, so these are the 3 use cases for Kubernetes. You can use a init container to instrument application. You use a Docker file to instrument applications. That basically means simply that you add the agent into the image and add the agent parameters, the system parameters when you start up your app. Pretty simple on that one. But the auto instrumentation portion is the one that's recommended most, and this is the one I'm covering here. And then here we were talking about, we've gone through all the steps to actually install the agent. But now we want to go ahead and look at some examples. For example, here we have some thorough examples of how to do monoliths, how to tune the agent configuration so that we are only picking up certain applications within the namespace. So there are different use cases within this auto instrumentation scheme. For example, you can go ahead and instrument everything in this namespace, or you can go ahead and only monitor certain deployments, certain applications that are deployed within that namespace. You don't have to pull in everything. So in this example, for example, example 1, what's happening here, let me just make that a little bit bigger for you. What we're doing here, aside from all of this was all was set to begin with using our agent cluster configuration that we did to begin with. But then we start adding the auto instrumentation scheme, which is basically how you hook the auto instrumentation into your application. Okay, and so then we start actually seeing your applications being auto instrumented. Okay, just want to make sure I have this YAML format correct here. So basically, I'm doing this, and let me just pull all this. So what I'm saying now is, okay, I have the cluster agent. Kubernetes is reporting metrics into AppD. I'm monitoring the health of the cluster. I'm publishing out alerts and everything. But let me go ahead and now look for a particular application that's running, or define what I want to do within that namespace. Do I want to monitor all of the workloads, different applications running within that namespace, or just certain ones? And this is how you actually go and configure that. Now, here, obviously, I was talking about Spring Pet Clinic demo too, but just keep in mind, this particular one, I am already instrumenting because I was running this example and I had it up already. I'm going to look at the other one that I have in another space, because we have all these different namespaces that I had deployed Pet Clinic into. I'm going to look at this one and auto instrument that. So what I'm going to do now, okay, is for one, let me see what's running in that namespace. Again, that's just another copy of Pet Clinic, right? So I can actually see that this Pet Clinic running within the space has this load balancer set up. So I can actually access this one as well and see the user interface and see that it's running and servicing stuff. I want to go ahead and also add that and configure that to be monitored. So I would actually go ahead and either add this to what's already monitoring, like I could go do this. Or, I can go ahead and configure a name, a regex to basically, look at everything in the namespace, or, whatever namespace that matches what. And then I can look at a particular application or give an application name. For example, I'm saying that I want to go ahead and look at this and say demo 8, 6, whatever. That's the name of the application within the namespace or the workload within the namespace that is called demo 3. And then I can go ahead and change things around accordingly. Here I'm saying demo 9. No, I'm just going to go ahead and configure that. I'm going to get rid of the rest of the stuff. I just copied it here because I wasn't sure about the formatting of a VI. And then everything else looks good. Okay. And in essence, I'm saying that I'm going to go ahead and monitor now another namespace that has another application workload running on it. And when you do so, then you go ahead and run it. Okay, now that will take a little bit of time for the things to kick in. So there's another option for you to do is to actually go into the cluster configuration if you wanted to and use the GUI, if you will, to add another namespace. So whereas this one that I was looking at has, if I look at it quickly here from the cluster agent management, when I brought this up to begin with, you notice I had only decided that in the configuration here, I wanted to only monitor a couple of namespaces. Okay, the main ones here, I'm obviously monitoring the AppDynamics itself. We saw that here, right? When I started this up, and then we also had demo 2. So those two namespaces are already part of here. I could go and modify this, imply it and wait. And then also there is the scheme where you can actually go ahead and add the namespace because, cluster agent is monitoring all of these namespaces. And I can actually go ahead and add the namespace demo 3 here as well, right? So now I'm going to start monitoring the pods that are coming off of this the third demo namespace called demo 3. It'll take a little while for that to kick in, but what happens from that point on is the fact that you'll see now the number of pods being monitored are going up, the namespace, an extra namespace is being monitored and such. And that usually takes a bit for that to happen and everything to start reporting. So that's the gist of doing the auto instrumentation and configuring the cluster agent to do that. That's it. Now we'll wait for that to kick in. While that's happening, we are going to go ahead, cover everything else here. Now with this auto instrumentation kicking in, we should start observing not just the namespace staff, but also start observing the flow map for the particular application, Pet Clinic, that I defined here. Okay. Now, in this scenario, we're going to go ahead and it should be called Pet Clinic Demo 9. And I would actually have to go ahead and reapply this in order to see the auto instrumentation kick in. All I've done here in this scenario, I've added the namespace to be monitored. I still haven't quite enabled auto instrumentation for that particular running Pet Clinic application. So what I have to do here is go ahead and normally the recommendation is to delete and recreate. I'm going to take a stab at this and see if I can actually get this reapplied. Okay, so it's actually what if I do instead of create, let's do apply. Configured. Actually sure if that would work in itself. I'm hesitant to actually go and delete everything on this because I wanted to make sure you see this cluster stuff here. So I'm not necessarily going to delete the cluster. If you look at the documentation, it says if you want to go ahead and kill the cluster, or rather stop the instrumentation, you go through and delete and then recreate the configuration. Okay, and what that does in effect detaches the agent monitoring from the running application, and then reattaches it so with the Java arguments that are necessary to report into the cluster. So those are some of the things, nuances in this documentation you have to look at. But the idea is that as soon as you have this agent configuration defined and you have your instrumentation rules, you can actually go ahead and create the necessary hooks into the application to be monitored automatically. Do you have any questions before I move on to the Docker portion of this?
Nothing at the moment, but a good time just to remind all our participants and attendees, if you do have a question for Alex or either of our speakers, please use that Q&A panel and we will answer it for you.
Okay, well, we'll wait for that to flow. If I were to check back and see how quickly the namespace is updated for this particular cluster monitoring, I'll see that 2 more pods were added, and then another namespace that was just added, and then demo 3. And we can go ahead and see that. Now, this portion, I think we still don't have the pet clinic, the one that I configured here, added. So what I'm going to do is actually use this scheme to go ahead and delete and recreate this so that I get this pattern pre-applied, because I want to make sure the auto instrumentation is kicking in. So what I'm going to do is go ahead and delete the agent monitoring, and if I now look at the AppDynamics namespace, I see that the cluster agent has been offloaded. Oops, right, at pods. And only, oh, do I have it? No, I'm so sorry. I just removed the, I didn't move it, or terminating rather. You see that I just terminated cluster, the cluster agent configuration. Operator is still there because operator, is hooked into the Kubernetes API and is monitoring all of these actions and hooked into the life cycle of the cluster. And so that's happening. And if I get look at it and see if it's been terminated, it's gone. And I'm going to go ahead and now recreate this and hopefully get this this new configuration with the pattern that's necessary, no errors there, and see the pattern applied. Now this cluster agent comes up, it has the new configuration patterns that it needs to apply, and it should start, we should start seeing Pet Clinic Demo 9 pop up for stuff that's coming in here. Okay. Let's see it yet. We'll wait for that a little bit. So I'm going to go ahead and move on to the next step, and we'll come back. Here we've gone through the deployment. We just a quick summary. We installed the cluster agent. We saw the cluster metrics come through the controller. Then we applied a pattern to do an auto instrument, application within that namespace, and you could have multiple applications running, or workloads, if you will. So you use the auto instrumentation and pattern that you're looking for to pull in specific ones. And then like I mentioned, we had different examples of things that are shown here that you can actually look at all of these different examples for different use cases. And then at some point, you'll see your application, not just the cluster that it's running on being monitored, but you'll see the pet clinic itself being monitored. Here, if I wanted to look at it, this is an older version that I had that was running, and this is a pet clinic microservice, I call it, but this is running off of a pet clinic server. This is a different version, a little bit more complex than the other ones, but you will see that it's like a pet clinic clustered version of the simpler version. Okay, if that makes sense. So in this scenario, that guy is running all these pods. There are multiple pods running because they're just configured as a microservice and not just a monolith. So you see different services running, and these services have backend databases, and you see them here. I'm not making any calls, so you don't see anything being persisted. But if I wanted to actually access, there has to be some traffic, right, for these things to start showing workflow, so or flow map arrows and talking to the backend. So if I wanted to, I can go ahead and get access the GUI, and then start run some traffic, and then see how that stuff shows up, and exercise some traffic so that I can see it sometime within the next minute or two with this flow map coming in, showing arrows. That's that portion. Now let me go ahead and jump in to the Docker agent management side of things. Now this has to do mainly with the fact that you have a Java application, you're running it within a container. How do you instrument it so it starts reporting to your controller, right? So with that, I don't have a full hands-on session here, but I can make a go at it here really quickly on my local environment. So if I go in here, I have already this created. I can go ahead quickly run this simpler version of Pet Clinic, not the microservice version, if you will. And if I just run this on my local Mac, it brings up the same application you saw here. But let's see if this has any more metrics reported for components talking to each other through this flow map. Yeah, so I hit the traffic and I started seeing some stuff, so you'll see it. Now here, this is running off of my local machine, so I can actually go ahead and show. This is running right here. It's nice and fast. You see it here. I can generate some errors, and so this is the local version. Now, what I wanted to do was actually start looking at Dockerizing this and adding the app agent. This is the portion where we're talking about instrumenting applications using Docker. Okay, this is our agent management lifecycle. If you want to just simply add monitoring to your containerized application, these are the steps you would follow through. Let me go ahead and show you. I just created this Docker file. Let me just make sure there's nothing here that shouldn't be. Okay, cool. So this Docker file is simply taking the Pet Clinic application, copying it into a container. There is a step here to follow with doing the instrumentation. How do you build out the instrumentation? Where do you pull the agents from? Again, you have to pull it from the download website. And here we can go and look at this documentation. It says use a Docker file. You go to the download site, and you go ahead. Again, this is the same place we pull in the cluster agent from. And in this scenario, I'm going to go ahead and change the cluster agent to a Java agent. And I'm running this on my Mac, but so you would want to pull in for sure your architecture bundle. And in this scenario, I can go ahead and pull in whichever one that we have available, whichever bundle that you have. In this scenario, for example, I can go ahead and pull in using this particular bundle. Okay, I do have that already somewhere. Okay, so I did pull it earlier, and this is how it unzips into your application. You see it telling you, walking you through steps. You unzip it and you have it available to go, and then you create your Docker file accordingly. Again, if you look at it, you see it says copy the pet clinic. This is the jar file that I want into the container, pulling everything within the app server agent and put it into a container target container directory called AppDynamics. Here's the important monitoring stuff that I need. Here, the access key, again, you see this access key for the cluster agent. Remember, we actually went through a step to generate their secret to do that. But this one here is where you plug in the access key. I won't show it to you now, but this is the other information you need to get everything up and running. You modify your Java agent system parameters, and then you run the pet clinic application with the Java ops system parameters. Okay, I'm going to go ahead and pull this in quickly and then give it a go. I didn't fully test this out, but I think we get this Docker file going. I just am going to add an access key here. Let me just go ahead and pull the access key from the monitor really quick. By the way, you can use licensing rules here as well, so it doesn't have to be the controller access key. You could actually use the account rules scheme, right? You could, instead of doing the account where you pull in this access key, you could actually use the rules and use the rule to pull in the access key for what you're trying to do. Okay, so I have modified that, and here what I'm going to do is now do a build. And I've already built this, so this should be fairly fast. And you'll see that here, Docker images. And what did I call it? Spring something. Oops. I think I was calling it standalone. Okay. So if I want to do that now, I want to see, let's give it a go. I think I was having some issue with running this, but that's okay. I have the image itself has an embedded Java agent in it. And you might see it pop up here fairly shortly here. This is is this the one? No. Yeah, I think that's the one actually. It did fail here, and I think that's simply because I built my pet clinic with a different version, I think, and quite honestly, I didn't have time to troubleshoot this, but you do see sort of this pet clinic come up, and as a Dockerized container being reporting to the application, have a workflow, and I think there we go. Pet clinic standalone monitoring. Of course, it died too early for us to be able to look at the stuff. Once you troubleshoot that, you'll be fine. That's pretty much what I wanted to cover in terms of the two main methods. Do you have any questions before I move on and hand over the presentation to Gary? He's a SME on Cloud Foundry stuff, and he'll cover the Cloud Foundry for you.
Yeah, we do have one quick question that came through the chat here, if I don't mind getting to it before we go to Gary. Rather than this is from Dennis, rather than download the binaries, can you set it so the Java binaries for AppDynamics agent pulls the latest when it builds from a pipeline?
Yes, you can. You just simply define the latest tag from a whatever registry you're talking about. Well, your pipeline could simply curl the latest version from the repository. Now, if you're talking about download here, in terms of like which version instead of latest version, I think I'm not 100% sure exactly where do you define this to be latest? I know people have done it. So rather than being stuck with the version, you want to pull in the latest, basically, basically. I'm not sure. Let me, I have to get back to you on that one. Is that the gist of their question?
So Alex, I'll just add to it. We do have images of these agents in both Docker and in Red Hat. So to Alex's point, if you use the latest tag and you're accessing any of those two public repos, then you can pull the latest version of that agent, which is a very common approach.
Ah, right. You're right. This is the one we're talking about here, basically, where, well, this is the Docker hub. This is, and then if you pull in the latest, for example, this machine agent, agent config, there's Java app server, Java agents here somewhere. Can I do a quick search here? See. There we go. So you could actually pull their latest tag, and that would give you, which version is this? It was deployed 24 days ago. So that would give you what you need. Is that in?
Yeah. And I will say this, usually our when we release a new version of an agent, usually the image for that agent gets built a couple weeks after that. So if we release a new agent in the download section, it usually appears a couple weeks before it appears in the image section. Within the two repos, Red Hat and Docker Hub.
No. There you go. Thank you for that question. Thanks, Gary, for that insight. Any other questions?
No, nothing at the moment.
Where is that repo in public? We're talking about Docker Hub, Dennis, right? Or I think that's what you're asking, Dennis. Okay, so let me go ahead and hand this off then to Gary. Gary, take it over and start out with your first slide here.
Yeah, thanks a lot, Alex. So Alex had the much harder presentation. Kubernetes allows you a lot of flexibility, and therefore you have a lot of things that you can do with configuration files to monitor, to deploy, to address your monitoring needs. When it comes to Pivotal Cloud Foundry, this rides on top of your AWS or Azure infrastructure. You can also have an on-prem version, but it's designed to be a little bit more user-friendly to developers in terms of deploying. You lose a little bit of the flexibility within Kubernetes, so that's why a lot of people like the Kubernetes approach, but still Pivotal Cloud Foundry has a big following. When we're talking about scaling with AppDynamics and Pivotal Cloud Foundry, it is very simple. So a quick overview of how we work with Pivotal Cloud Foundry. Once you have Pivotal Cloud Foundry deployed, what you need to do is you grab the AppDynamics tile. And you can flip to the next screen here, Alex. You grab the AppDynamics APM tile. And once this APM tile is configured, what it does is it sets up a PCF service. And that service can be used by any application team. The application team simply have to grab that AppDynamics service. And once they grab that service, they can use that service to automatically deploy the AppDynamics agents into their different microservices that they're running within Pivotal Cloud Foundry. One other thing that your PCF administrators would need to do is make sure that they grab the AppD build pack. The way we work with Pivotal Cloud Foundry is we work with them to embed our agents into their standard build packs. So every time you download a new build pack, for your developers to use. You're downloading all the components you need in order to run AppDynamics. One thing to remember, as I mentioned before, make sure you also include that AppD build pack, which is specific functionality for our product, right? So you get all your build packs, get AppDynamics build pack also, you deploy your APM tile, you're good to go, okay? You may notice from the screenshot here, I captured from the Pivotal Cloud Foundry site just the latest version of both our APM tile and our AppDynamics build pack. So very easy to take care of. So once you have those two, once your Pivotal Cloud Foundry administrators get the APM tile and the build packs all set up for you, then all you have to do is update your manifest. The two things that you need to take into account, which we'll look at some examples here in a second, you need to add some environmental variables, and then, right, we scale based on those instances. So however many instances you define within your manifest, as long as you have grabbed the AppDynamics service and your microservice is using it, we will automatically deploy those agents to all those instances. So one quick point of clarification for those that may not be familiar with Pivotal Cloud Foundry. Think of an instance as simply a container, right? Just how Pivotal Cloud Foundry defines their containers. So I grab my application, I get my manifest, set up, I deploy my application, right? I grab my service, AppDynamics service. After I've done those things, I just restage my application. I can do it from Ops Manager or simply CF restage if I'm doing it command line. And then all of a sudden, bam, I have my AppDynamics deployment added to my microservice. So next slide, please. So here's how simple it is to deploy AppDynamics and to scale it with PCF. Notice here I have a very simple manifest. The name of my microservice within Pivotal Cloud Foundry is called Microservice A. I then define what my instances or what my containers are going to look like. I have one gig of memory. I'm just deploying one instance or one container. Here's the path of the application that I'll be using to deploy into my container. And I'm using a Java build pack, right? This is a Java microservice. Very straightforward, right? Now here comes in the AppDynamics side of it. First off, remember, we work with Pivotal Cloud Foundry to integrate our components into their build packs. So you're using the Java build pack, but our AppDynamics Java agent capabilities are within that build pack. So what I need to do is I need to go to services, right? Add a services section. I define a new AppDynamics service, right? So whatever my tile is named becomes a service in Pivotal Cloud Foundry. I then grab that service. So I'm incorporating that service into my manifest here. And that makes sure that I pull in my AppDynamics service, right? And I can name my services whatever I want. I can name it AppDynamics. It could be named Cisco AppDynamics. It's whatever you want to name it that corresponds to that AppDynamics APM tile. So after I incorporate my AppDynamics service into my manifest, then I use some environmental variables to make sure that everything that appears in my AppDynamics controller is as I want it. So an application is made up of many microservices. So I have the ability, if I have 10 microservices within my application, I have the ability to group all these microservices into one application view in my controller. I do that by using environmental variables. Here, I use the AppDynamics agent application name, and I call it dev movie stream. If I have a microservice B, a microservice C, a microservice D, and they all support this movie stream application, then in my manifest for each of those microservices, if I add this label, it will appear in the controller under the application name dev movie stream. So in my controller, I have these 11 microservices now, right? Grouped under this one application. But I want to make sure my microservices are differentiated from one another. How do I do that? Each microservice is its own tier. So I have AppDynamics agent tier name, and I call it ratings microservice. So what I've done essentially is say, I've made a big bucket that says group all my microservices under dev movie stream, right? Then to make sure I differentiate each microservice the way I want, I use the tier name, right? And then my nodes would be automatically defined based on my instances that I deploy, right? Node equals a container in this case, or an instance, and that would all appear in my AppDynamics controller. All I do is add this manifest, do a deployment if I've never deployed it before, or a restage. Bam, AppDynamics is deployed and showing up in my controller. Takes about 5 minutes to get everything set up. Can you go to the next screen, please? Notice that I did mention about an AppD build pack. Outside the Java deployment, all the other languages that we support in Pivotal Cloud Foundry require the AppD build pack. It has some special functionality that's put in there, and we use a separate build pack because we want to recognize Pivotal Cloud Foundry's 12-factor application deployment methodology, right? Very famous methodology to build microservices. And it's not just based on Pivotal Cloud Foundry. It's just, a very common framework. So what we did is we built in some functionality specific to other languages that we include in the AppD build pack. So outside Java, you would use the AppD build pack. You want to specify it first in your manifest under your build packs, and then you specify, your standard build pack for your language. So here, I'm deploying .NET Core. I need my AppD build pack. I specify it first. Always needs to be specified first. Then I use my .core build pack, right? I have my service again, AppDynamics, and then I have my environmental variables. I say, hey, in this case, the AppD agent I'm using is .NET Linux, because .NET can be deployed to Windows, it can be deployed to Linux. Here I need to define exactly how .NET's being used. So I have AppD agent environmental variable. Once again, I have my AppDynamics agent application name, right? Notice this is microservice B, but it's going to be grouped under dev movie stream, the same place that microservice A is located under. Then I have a tier name to differentiate this microservice from every other microservice in my controller. And finally, I can do something a little bit fancy here. And if I wanted to, I can pull a different version of my agent using this AppD agent HTTP URL. So in this case, I grabbed the latest version of this .NET Core from my download site, AppDynamics download site. I put it on my internal Git, and I reference it. It pulls in the agent at build time. that's it for deploying AppDynamics with Pivotal Cloud Foundry. If you have any questions, if you go to the Pivotal Cloud Foundry site, you search for AppDynamics APM, it lists all the environmental variables you can use, as well as the different languages we support. And if you have any other questions, certainly post them to chat. I'm happy to answer them. That's the overview of how to deploy with Pivotal Cloud Foundry. Any questions that we have in chat, Tanner?
Yeah, there's just one that came through. Gerard, thanks for responding to Dennis there. Dennis, thanks for plugging it in. And just a reminder to our attendees, if you do have a question, please use that Q&A panel to submit your question. Allows us to filter a little bit better. Let's go to this question from Matthias, and feel free to whoever would like to take this one. How can we deal when customers use Python frameworks such as Streamlit, Flask, or Gradio, for example? Is the AppDynamics agent compatible?
So yes, it is the answer. Python can vary in some aspects, but you should be able to. There's a Python build pack for Pivotal Cloud Foundry, and I know Python also can be deployed within a Kubernetes environment.
Perfect. And I am going to go ahead and read another question here from Dennis. I know Gerard just shared a link with him, but just would be good to cover if you don't mind. Are you able to quickly touch on how AppDynamics integration works with serverless functions? In the case of AWS Lambda functions, do you have hooks into CloudWatch, or do you do this some other way?
Yes. So the answer is it depends. In our commercial SaaS platform, we have a way to instrument these AWS serverless functions, and it's not through CloudWatch. There's some documentation that those, our folks will probably post here in the chat. In our CNOW product, which is our cloud native product that's specific, it's kind of our next gen product, I would say, for cloud native applications. We do a combination of CloudWatch, and we're working on some other unique ways to handle that also. But for CSaaS, it is not through CloudWatch.
Perfect. Thanks for answering that. At the moment, it does look like that is all for our Q&A and our time. Gary, I'll start with you, and then we can go to Alex after. Is there anything that either of you want to touch on before we wrap up?
Yeah, no, we really integrate well with these cloud technologies, and it's you saw with Pivotal Cloud Foundry in 4 simple steps. You grab that service that gets set up by your administrator. You change your manifest and add some environment. By adding some environmental variables to a restage, and you're good to go. So yeah.
Great, thank you. Alex, do you have anything you would like to touch on before we wrap up?
Yeah, I just wanted to point out some resources available. If you're looking for help in pre-sales, obviously you talk to sales engineers and consultants. If you're going through and you have already services, you can look at professional services. Of course, we're a customer success team here as well, and we provide training and enablement to our customers. And there's great resources at the education portal where you have a lot of different content, short videos, and also instructor-led courses that cover a lot of stuff. There's tons of material also available on YouTube channels. And so those are all the resources you can look at asynchronously as well, watch videos and on different things that we just wanted to do a shout out for these tools as well. That's about it.
We really appreciate it.
Thank you.
Really appreciate it. Great job today, Alex and Gary. Thank you so much to both of you for bringing your knowledge to the Cisco community today, as well as our panelists who are able to attend today's session. If you do have a question for either of our speakers, we'll keep that Q&A window open just for a couple more moments. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. It usually takes about 5 business days for today's session to be uploaded to our learning plan, so keep an eye out for that. I have provided the link in the chat to where those recordings will be made available. I've also provided a link in the chat to our post-webinar discussion thread, which will have the link to the recording as well and allows you to follow up and ask some further questions if you go back and watch this session at a later date. Your feedback is important to us, and at this time, you'll be directed to a post-webinar survey. Please take the time to participate in that. It helps us plan out future sessions. Once again, we thank everybody for joining us today, and we will see you next time on the Cisco Learning Network.